Oh, take a look.
Oh, I take the beamer, okay?
Okay, so it's not fixing the IP version 6 problem, but it's fixing the IP version 4 problem with IP version.
Is the problem with processing 6 important and to random
Test IPv6 als allererstes. So. Ne, das ist ja rausgekommen, das ist ein Minus sein, das ist noch weggefallen. Der Test ist jetzt IP version 4. Okay. Ja, okay. Do you test it?
Yeah, it's in the socket code area.
Okay.
And do you want to start? So it was really easy, no? So just rip out the IP6.
In 1 minute.
Yeah, and the relative distances of the rest of the data, so it doesn't matter. You just remove the prefix. Okay, yes, makes sense.
Okay, guys. So, recording? Okay. So this is a beginner's presentation about Git. So who's already friendly with Git can continue to his work. The idea of this presentation was to make something also like entry level for people that are new in this community and maybe want some helpful hints on Git. So don't expect any rocket science from here. Also, okay.
Wrong sound. We said rocket science.
Rocket science, no? Okay. So why Git? Who am I? I'm Zio Prato, and I had to learn Git because of the Google Summer of Code, because I did mentorship for a student that was working on AllSR, and my work on AllSR basically did quit when they moved from Mercurial to Git, because I had a hard time managing the new tool. But then I had to do this mentorship, so I said, okay, it's time to get to study and understand this new software, otherwise I will not be able to do the mentorship. So I have to thank him. Okay, here is just, I recycled this presentation, so there is a beautiful picture of me when I was young, and I use Git also at work. I work at GAR, that is the research network of the Italian universities, so I do knock there, and I do knock at Linux, so I'm 24-hour knock. Okay, first of all, if you want to follow for this presentation, you have to forget all you know about other versioning systems. So if you use daily SVN or CVS, or you've seen that stuff in the past, please forget everything or you will get confused, okay? Okay, so the first part is about forgetting. You have to forget about client and server, or you will not be able to understand what's going on later. SVN, how many of you use SVN? Many, alright. And how many of you use Git already? More than SVN, so good, very good. Alright, so forget about client and server because there is not client and server here. And when you do the git init command in an empty folder, that will create a .git. Then this .git is a hidden folder that contains all the database that needs to work. So this database is called object store in the Git language, and it's not mandatory to know about this object store, but if you know how it's done, it's very easy to understand the commands, in my opinion. So let's have a look at this object store. So in Git everything is local. You have this object store, there is a database of all the data of your commits, and there are 4 object types. The first object type is a blob, is a binary large object. It means it's a text file or is a binary, it's just some data that is in your repository. Then there is a tree. A tree is an object that represents a directory. So it's basically a list of all the files or other directory, okay? And then for each one there is also some bits about the permission of the file and the name of the file. Then there is commit. A commit is nothing else that some metadata like a username committer, some timestamp, and there is a reference to a tree. And then there are tags. Tags are very easy, are just like human names that are connected to an object, so that we can call stuff like version 2 instead of the commit hash. Okay, each one of these object type, there are only 4, so the whole database is done only of these 4 object types. Each one has a name, okay? I mean the particular object has a name. What is the name? Is the SHA1, the SHA function, of the content of the object. We see an example. So, okay. I always put very funny pictures to make the presentation more, you know, to wake up the people. Okay. So you see, you get. Thank you. So, okay, so we say we have this database with 4 object types, and for every object has a name that is produced doing the SHA1 of the content. How you say this in English? SHA1, SHA1, what's the correct? SHA1, okay. So let's make an example. Here I do git init, and then if I do ls.git, I see that I have this git folder. Inside there is a subfolder called objects. Then I will create a file, add this file, git write 3, that is not really a command that you use daily, is more for didactics, you know, to understand. Okay, so when I add something to the git database with this command, I see that the object folder starts to get populated. Now I will show you. Okay, so basically, can you read? Yeah. Okay, so I go in an empty folder, and this is empty, okay? Believe me, it's empty, alright? Now I do git init. Okay, and it also prints it out. Anyway, yeah, you can see there is this empty folder, okay? That is the container for the database. And then here, I have objects that there are these 2 folders that I don't even know what they are, okay? But this is empty, basically. So now I touch a file, and maybe I also want to write some bullshit inside. Okay, then I do git add this file. We will see later what happens with this git add, okay? And then I do git okay. So what happens now? With git write 3, I told to git, please create a 3 object in the database that represents my index at this moment when I added this file. So if I go to the object store that was here, I can see I have 2 subfolders, 05C0. Let's see what's inside 05, and you see there is a file that is a SHA1 name, okay? So this is one of the objects of my database. Okay, now there is a tricky thing that is not obvious. Why I have these 2 folders? Because if I have an object store, so it's a database where every item in the database has a name of SHA1. Basically, I have a folder with tons of files, okay? But the Linux file system, X3, X4, whatever, do not manage very good a single folder with billions of files. So we implemented Git. They said, okay, I have this object in the object store where the name is 05, DC, D4, so on. So to store it in the file system, I will make in a way that the first 2 digits of the SHA-1 is a folder and the rest is the file. Did I explain myself? Okay, so this is why it's organized like that. It's just because of a file system limit. Okay, so now if I go to look into this one, I can do key git cat file O5DC. Okay, I don't have to write out the whole thing. All right, if I just write the beginning of the SHA-1 and there is only an object in the database that starts with that, Git will understand. So if I ask Git the object from the database that the name is O5DC and so on, he will print Linux, because you remember in the file we wrote Linux. All right. Okay. You see that this object here it loses its file, the file name. The file name was file. Okay. There is just the content and the object in the database. If I do SHA-1 of Linux, you will have this result. Okay, so how do I get my directory structures? With the tree, I see here that there is another object in the Git database. If I do C0, C00C, okay, you will see this is a tree object. The tree object tells me this is permissions of the file. This is a blob object. This is the SHA-1 that you will find here. Oh, well, 05DC. You see, 05DC, and the file name is file. Okay. So this is the way the Git database works. All right, but don't worry about this stuff. It's just important that you have a rough idea. You will not use these commands daily when working on your projects, but if you're doing some advanced stuff and you do some big mess, you really want to know how this stuff works to get your commits out before you lose the work of some months. Okay. So let's talk about the Git index. The Git index is the really new thing that is not in any other tool that I used before. So basically it's a dynamic temporary file that describes your directory structure. Okay, so when you do some change in your working directory and you do git diff, you will see these changes. Okay, to keep track of these changes, you can add them to the index with these commands that are listed here, that are git add, git remove, and git move. So you continuously update your index. All right. It's I will make you an example. So here now, if I do git status, whoops. Okay, it tells me there is a new file. Okay, file because I did git add before. If I create test.sh and I do git status, it tells me, alright, you have a new file here, is in red, untracked, I don't know it. If I want to add it to the index, I do git add test. Okay, now it's in the index, I will find it here. But what happens if I modify again this test here and I add some more content? Alright, now if I do git status, this is very the point. Try to understand this. Now it tells me there is a file that is on track, that is test.sh, and there is a file in the index called test.sh. Now it means he keeps track of the file that you did git add, even if you didn't commit anything, and of the new file that is the last modification. Look, if you do git diff, this is the diff between what I added to the index and what I have in my last commit. All right. So in the other systems there was just what's in the working directory and what's to commit. This is an intermediate step. Okay. So you have to learn how to handle this. If you commit at this point, you will commit this version of the file that you did git add before the second modification. Okay, so let's look how the index is related to the files that I have in my working directory. A file can be tracked, so it means when a file is tracked, it's staged in the index. So it means in my object store I have a version of this file, so I'm tracking it, and when I make modifications, I am able to track these modifications because the file is already in my database. Then I have ignored file, like similar to SVN ignore. It means that I have a special file called git ignore. Everything I write in there, git just ignores, doesn't see it. And then I have untracked file that git doesn't know about them. Question?
No.
Sleeping, okay.
Yeah, about the ignores. If you have already stored a file in Git and you then add it to the ignored files, it is not ignored.
Yeah,
Because
correct.
Git thinks, well, you put it in the repository, so I have to track it.
Yeah. Yeah, make sure, if you want to ignore it, make sure you do git remove, you make a commit when you delete it, and then you add it to git ignore. I'm going too slow or too fast?
It's fine.
It's fine, alright. So, now we can talk about the commit. So, what's the commit about? Now, if you understood the index, the commit is very easy. You just get the index at a certain point. So, I'm working in my working directory, I do git add, and I add all these versions of the files that I want to freeze. I have this situation in the index, and when I do git commit, I freeze the index, and I attach to this tree a commit object, okay, that is a pointer to this version of the index. It brings with it a timestamp, it brings with it the author of the commit, and some other metadata like the previous commit, okay, that I'm linked to. The commit is done by the user, but it's also possible that when you merge some stuff, the Git makes a commit by itself. Okay? Let's see. Okay, let's see how to look up these commits. Here I wrote refs and simrefs. What is this stuff? Okay, we said Git objects have names that are the SHA-1 of their contents. Alright, so any Git object in Git can be referenced with this SHA-1. So I can always use that reference, but they're not very handful to write. So there are some symbolic links that I can use, and there are some ones that are built in Git. The most common are head, that is the current commit where you are working on, and then there is orig head, that is the head at the step just before. Sometimes when you do mess up everything, you want to roll back to that. And then there is fetch head, that is if you download from a remote repository, that's the head of the remote. We will see better that later. So here's some example. Checkout is a command that means just load in my working directory this specific commit that I'm requesting. So I can do git checkout and this specific commit, and I will have in my working directory the files as they were when I freeze that commit. Or I can do checkout head tilde 1. It means this tilde is special. It means go to head and then go back in the tree by one position. This can be 1, 2, 35, whatever. And then, or I can do git checkout or rig head, okay? That is the head before the previous commit. Okay, all these one I suggest you to have a look at the Git book, you know, because I cannot explain all of them. This is just to give you an idea. Okay, this is very important. This is why I put a picture that explains. A commit knows its parents, but not its child. What it means? Okay, when you commit, in the commit I say there is some metadata, alright? Metadata, the timestamp, the name of the committer, and also there is a reference to the parent. It means when I commit, usually I start from another commit, that is the head, and I do a new commit. So the new commit is linked to the commit that is his parents. But of course, there is no link to the child. This is important, okay? Because when we will talk about branch, this is fundamental. So keep in mind this, okay? Now we go to the branch. Okay, branch really is branch really is easy if you don't think of branch as folders, okay? A branch is not a folder. It's not like SVN where I get all my work, I copy it to another folder, and then I start work on that different folder. Okay, we're not talking about this. A branch is a reference to a commit. I want to make an example, or it's not possible to understand. I will get some repository that I know, like OLSR, where I have a lot of branches. Let's take, a lot of stuff. Okay, here is fine. Okay. So what we see here, this is my repository. So it's a database with a lot of commits. All these ones are commits in this view. Every commit is named with a SHA-1. And also, I say there is some refs. For example, you see this is my head. Can you read head there in blue? So that's the commit that is loaded in my working directory. And then, for example, up there I have some other branch that is called Fox Hickerman's Zubrod, okay? So it means when I'm working on a branch and I do a commit, the branch label is moved to the further commit. I will show you this. So here was here. Here never committed anything, so just okay. So let's see this. I have just a single commit, okay, where I committed these files, and this is my head, and this is called branch master, okay. Now if I do I create a new file, git add more files to add them to the index. Now I want to freeze this situation of the index. I will do git commit, I put a comment, add more files. And now let's look what happened. Okay, this was my branch master, okay? When I did the new commit, the master moved to the new commit. Why? Because master is just a symbolic link, okay? And these two are linked together, okay? So in master, I have a reference to the previous commit. This is why I can graph it. I say, hey, look at master and draw all the history to the beginning of the repository. So, and this goes on. If I do again git, if I do again to touch battle mesh.sh, git add this. Okay, what happens now if I want to start a new branch, alright? So starting a new branch is as easy as saying I want to start from this situation of the repository that I freeze, okay? And I want to keep track of another line of coding, alright? So it means I have to go here with my head to push this stuff out in my working directory and put a label to keep track of that. So I just do git checkout. I want to check out this, and I do branch, and I call it battle mesh. Let's see what happened. You see now I'm here, and here I have this branch label battle mesh. Now if I do a new commit from here, I put another file, my new file commit, I call it first commit new branch. Okay, you will see that it forked. Okay, I have my head in the branch battle mesh. That here it is in red. I don't know if you can see it. So here I have a reference to my parent. Okay, and here there is the master branch. So this is really like a database. It's not like folders. Okay. So anytime I want to go to a specific version, I just do git checkout. I can check out calling this shy1. I can check out using the branch. Okay. So when I will commit, the branch tag will follow me. All right. To know in which branch you are committing, you just do git branch. It will print the branches and the active one. All right. To delete a branch, let's say you don't want it anymore, and now this is very fun. Like for example, I don't want the master branch anymore. I just delete the label. I don't need to delete actually the data. If I delete the label, git branch delete master should be like this. I deleted the branch master. If I look again at the graph, now there is only these 2 commits in the repository. Why I don't see any more of these commits? Why?
Because they are not referenced by...
They are not referenced, exactly. Because I have a battle mesh that knows its parent, but this commit doesn't know these 2 childs, but these childs are still in the database. If I do git checkout of this old commit, sorry, wrong one. So this is A37B85. I can still check out because it's in the database. Only I remove the reference. Okay. Now I did something that is for beginner is confusing. I asked it to check out, so to load in my working directory a commit that is not labeled with a branch. Okay. Is a commit in the middle, for example. So Git tells me, okay, I loaded this commit in your working directory, and you can look around, but now you cannot commit from here. Why you cannot commit from here?
You can, but those commits, all that branch will be...
You cannot, because you are not on any branch. When you commit, the branch that you are on will be moved to the new commit. But in this moment, you are not in any branch. You just committed, you just checked out a random commit. So you cannot do a new commit. Otherwise, that commit also will be unreferenced.
Yeah.
So you have to check out a branch and.
In fact, you can commit, but you have still it's still not referenced anywhere. Even the message on your screen says you can do commits. The point is just, as the 2 commits that are not referenced anywhere anymore.
Yeah. Okay, so it makes you commit, but then it's lost. Okay, I thought it wouldn't let you commit. Okay, so this state is called the touched head. All right, but if you are in the touched head, it's very easy. You'll see it. Git branch, it will say no branch, and then you just do git checkout head branch new should work. Yeah, and now what was master before is new. Okay. Don't worry about leaving unreferenced commit in the repository. There is a garbage collector that will clean them somehow, sometime. It's not really important. Alright. So let's go at the very useful stuff like diff. Diff in Git is very powerful. At the beginning is a little confusing because a lot of stuff is implicit, so you really want to know what you are diffing. If you just go diff, you will diff working directory and index. So working directory and index means that if now I do git diff and I have whoa, why? Okay. Yes, I modified the test.sh in my working directory and I see the difference. But when I do git add, then I do git diff and it's empty because it's already staged in the index. So if I want to see the difference between the index and the previous commit, I do git diff cached. Okay, just know the difference, and then when you will start to work on this, this will be very useful. But the really good stuff is that you can compare any two commits. So for example, if I go to a big project, for example, let's get all as R. So I can do git diff from, let's say, okay, for example, I want to diff version 0.5.1 and version 0.5.2. So these are two commits, and I want to see what changed in the code. And you get the diff, but this is not very useful. What I like to do is --stat. And this will give you a statistic of the files that changed, so that you can easily have an idea of what changed. For example, you have the new version, and with this git diff stat, okay? And you can diff any two objects, like, okay, these are two tags that I didn't talk about yet. Tags are nothing difficult. Tag is like you get a specific commit, and you give it a symbolic name that never changes. So a branch will change. When I commit, my branch will move. A tag just stay there. It's a label, a sticker to a specific commit. So git diff of the two commits will give you this output. You can do git diff of two branch. It means that it gets the current commit of that branch and the current commit of the other branch. We can make the example like from this version and, for example, master. Yeah, and we see there are many more changes. Okay, we can also we can also restrict this to a specific folder. I want to know the diff between this version and master. I do stat, and then --, means I finish giving commands. Now I give some files restrictions. I do libs, and this is just the change in the all these R plugins between those two. So diff is very powerful. Then there is a special diff that took me like 2 months to understand, and it's with the 3 dots. This I have to make a drawing to make you understand. Okay, say you have a repository like this with a lot of commits, and this is your master, okay? And then from this commit you started another branch that is called dev, alright? Now if you do git diff from master .dev, Git will do this for you. It will go to master, it will go back to the point where there is intersection with dev, and it will make the diff between this commit and this commit. Okay, if you don't put the 3 dots, it will make the diff between this commit and this commit. Okay?
3 dots or 2 dots is the same?
2 dots didn't work for me. 3 dots works. Okay, then there is git merge. Okay, git merge, it's easy as far as you keep in your mind some few rules. When you merge, you are always modifying your active branch. It's different to modify master into dev or dev into master, okay? So let's say you are on master, okay, and you want to merge dev. It means that you are creating a new commit here, okay? Create a new commit, and this new commit takes all the modification that you had in dev. And the master label moves from here to here. Okay? So always the active branch is the one that you modify with the merge, and you merge the modifications from another branch. Okay? In a way that all the changes introduced in these commits will be reflected here. Alright? So you can have a new commit with two parents. Okay, this is pretty new. You can have this commit with two parents. Because here, there are all the changes done in here, 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 and here. Agreed? Easy? Okay. Okay, cherry pick. Cherry pick is very useful, and also git revert. I use them daily. Let's go back to this example. So let's say I have a situation like this one, master and dev. Okay, at some point, let's say dev is like many commits, okay? At some point in this branch, someone push a commit that I like. Like for example, I like this one. Let's call it C0DE, okay? Code. So I like this commit, but I don't want to all the features in this branch. So I'm here, I'm in master, I do git cherry pick this commit shay1, and it will take just the difference in this commit, and it will add this commit here. Okay, and move master here. Note that this is not the same commit. This will be a different commit, because it's a different change. Okay? And also the time of the commit is different. It will create a new commit that introduces the same diff as this one. Okay, git revert is easier. It will create a new commit that reverts the change in a specified commit. So if I push something wrong, then I go git revert of that commit, and it will reverse the differences. You want to see an example of this, or? Yeah? Okay. So for example, whoops. Okay, what was the situation here? Okay, I am on the battle mesh branch. No, I am on the new branch. So I do git checkout battle mesh. Okay, so for example, I see at this new branch, but I don't want to merge it all. I'm just interested in this commit called add more files. So what I do is I do git cherry pick, and this is called, I copy this one. Cherry pick failed because I have local change. Let's see. I will tell you later. Okay. Okay, now I'm clean. So I'm clean, I'm in the battle mesh branch, and there is another branch. I like this commit, this specific change. Maybe I want to see it. I do git show this one, alright? I like this change that introduced a new file, okay? That is just called add more files, the file name, okay? I do git cherry pick and it's added here now. You see? Add more files. But it's a different SHA1, okay? Because it's a different commit. The content changed.
Maybe you should mention that it's not just added, but it's in fact there's a merge involved. So Git tries to track how similar it is and tries to adapt it to your local situation. And might even say, okay, I'm not sure how to commit or how to add this.
How to apply this patch? Yeah, Git tries to get that patch of that commit and apply on your current situation. Okay, if I want to revert, because I changed my mind, I do git revert. Now I want to revert this commit here. So here, for example, it's the same. If I write 864F9, or maybe I write head, it's the same. It means the same commit. So I can write just head, that is shorter. You see, and I have another commit, revert more files, that will apply the inverse patch. Okay. Altering commits. What we have seen until now, it's all safe, okay? All that we see until now is safe. It means that you can do this stuff without problem, because you all the operations that we see until now, they just add new commits to the repository. You always add. Now, if you studied SVN, in SVN, once you commit something to the repository, to the server, you cannot remove it anymore. It's there forever, okay? In Git, this is not true. You can always alter your repository. So a commit is editable, all right? Of course, you can do it if you didn't share your repository with somebody else. Because if you alter your commit history, then who received the old copy of your repository will not be able anymore to sync with you. So keep this in mind when you're out. So if you push something for GitHub and it's there for 1 month, and then you want to alter that, it's not a good idea, because if somebody downloaded that version, then they're not able anymore to give you commits. We see this in detail.
Well, but it's more complicated.
It's more complicated, yeah. Why? Let's see. Okay, I have a very easy Git repository with 3 commits, and this is master. And I put this in the GitHub. Then somebody download it, and this is on his computer, master, okay? Then eventually, this guy makes a new commit, master, okay? When he wants to give this commit with you, he will tell you, get my new commit. You have to attach it to the commit that you already know, that is this one. We call it C1. This is C1. So I get this little ball. I say, okay, his parent will be C1, and I attach it here. Okay? Clear. Okay. But now, what happened if I change my mind and I take this C1 and I want to change, for example, the commit description? Okay? So Git makes me do that, but if I change the description, the content of the commit change. So the name of the commit changed because it's the SHA1 of the content. So this is not anymore C1, but it's CX, okay? So when this happens, in this repository, there is not C1 anymore. I get this, and I do not know where to attach it. Okay? So this guy is not able anymore to push. Alright? I don't know how you solve this. Okay. Maybe you have to... You can solve it, but there is not a standard procedure. Okay, keep this in mind.
The rule is don't change your commits when you have them public.
Yeah.
Better revert them, so make a second commit that undo the first commit, but if you want, only edit things when you have not pushed them out when they are just local.
Yeah.
Git is a real Unix tool in the true tradition. If you want to shoot yourself in the foot, that's entirely possible. So
Yeah.
Git will do whatever you want it to do, but if you follow the simple rules, it will.
Sorry? Push force. Yeah, okay. What will happen with push force here?
Push force will just override.
Override, yeah. So you push this, you do this push force, and if this guy here, after Cx, did another commit, Cy, you will push force and Cy is lost forever. You understand?
Even CX will be
Yeah.
most likely lost.
Huh?
It's never lost.
The point is, it's still in the database, but your force push might move the master label
Yeah,
somewhere else.
exactly.
And so you have this epsilon, so you have all commits still there, but the label gets pushed around in a way that's not safe. That's why you need force parameter, because Git says, yes, I could push this, but this history doesn't make sense anymore.
So
Alright.
if you have to push force, you're doing it wrong.
Yeah.
At least most times.
Okay, so now let's see the very interesting stuff that we can do with the Git rebase. So Git rebase, for example, is, we have seen merge before. We have this master branch, and then maybe from here I have dev branch. Okay? We have seen before, if I do a merge, the merge will create new commit, okay? But I can rebase dev on top of master. It means I am on the active branch dev, I ask git rebase on master, it will take this patch series and it will reapply them on top of here and move dev here, okay? And these, of course, will alter these commits because they have different parents than before. Okay? We make an example of that, if you like.
This is not beginner stuff. Usually it's better to just merge.
Yeah, but sometimes, sometimes you can rebase on top of the latest to see if, well, maybe it's more, I don't know, taste, you know? Depends on your taste.
I usually prefer the rebase because it makes it clear what goes on top. I like to avoid merge commits if possible.
Yeah, I like rebase also because I don't like the graphs with the loops, you know, I'm a
There's
routing
lot
guy.
of different opinions on that. Linus, for example, says don't ever rebase. I want to know where this came from.
Well, but he was referring to rebasing public repositories
Yeah.
mostly.
Rebase is a good private tool, but again, it can shoot you in the foot pretty hard when you do it with with some commits someone else already based another commit on, similar to the forced push. So
By
yes,
the way, we can make an example. I have these two branch here, new and the battle mesh, you see? So I can say, okay, let's get branch new. If I do rebase on top of battle mesh, Okay. So you see that there is only one commit that is here. Why is only one? Because another commit, you remember, we already cherry picked. This is the old situation. You see that we have the add more files, and we had it also here. So now I did rebase, and he just took this one. You see, now it's a single line because I did rebase. If I did merge, I was gonna have on top a commit with two parents, a new commit.
Yeah. But again, rebase, what Perry said, is a little bit more advanced tool, so be careful that you understand what you're doing before it can really mess up a repository.
Yeah.
Hopefully only the local one.
Okay, so if you want to mess up even more, you can be a very Git ninja and do the rebase interactive. This is something I really like because when I work, I like to commit every single thing, all right? But when you commit like every single thing, like I change a line and I commit, like try this, try that. When you want to share this with someone else, you cannot go through 100 commits, you know. So when your stuff works and you want to deliver something that makes sense, you can rebase interactive and squash this commit in a bigger one. Let's see it. I will make a new branch to make you understand this. So git checkout head branch rebase. So I created a new branch tag. It's called rebase. Okay, and then I will do git rebase interactive, and I will start from here. Okay, when I do this, it opens an editor in an interactive way, and you can see all the commits. Okay, starting from the base that you choose. Okay, let's say these 4 commits do not make sense separate. It's enough in a single patch. Then here there is all the instructions always, and I will say to them instead, just pick the first one, and the other one I put an S, that means squash with the first one. Alright? So I save, and now it's telling me this is a combination of 4 commits. Please write a comment that makes sense. So I delete all this stuff, and here I write this is a commit combination of 4. This makes sense, for example. Okay, so now this branch is rebased. Let's see how it looks like. Okay, look, there is a single commit here in branch rebase. This parent is directly the root of the repository. Alright, and here is my old branch. Of course, now if I do git diff of rebase and new, they are exactly the same. But in one case, there is a single commit that describes all together. In the other case, it's all split up. Okay? Of course, this is altering the repository, so do it only before releasing to public. But this is very good. Like when I worked in the past with SVN, it was a pain because you can only commit when you're really sure, because then that commit is in the repository forever. With Git, you can feel free to commit and commit because you can always roll back and change your mind. This is not easy, so if you want to make questions on this, we're fine. Okay. Let's go to git reset. Okay, git reset also is a great tool. It helps you when you do a mess, okay? And it helps you if you want to do a mess, so be careful. We say the branch, after all, is just a sticker that is attached to a commit. Agreed? And if I commit, this sticker follow me. but the tool is so flexible that I can take this sticker and say, hey, I don't want this sticker here anymore, move it to another commit. So for example, now that I did rebase and that everything worked, maybe I want my new branch to be here, like the rebase, you know? So I can do git reset, I can do git checkout the new branch, and then I say git reset to rebase. And see how the repository looks like. I just moved this label and I stick it to the commit that I like. Okay? So this is very useful. For example, if I commit something bad, like touch one file, and I add it, and then I do commit, this is crazy. Okay, so now my new branch have this commit. This is crazy. I'm totally wrong. I didn't have to commit this, alright? I just do, well, okay, git reset to head -1, tilde1, sorry, it's not minus, it's tilde. And this will just get the label new, and it will bring it to the commit that I want. And that crazy commit is not in my repository anymore. Alright, so git reset is really flexible. You get branch tags, you move where you need them. There are 3 kinds of git reset. If you do git reset soft, I never used it in my life soft. Just moves the head to another commit. I never used it. If you do git reset mixed, that is the default. It left unchanged your working directory. It just affects the database, but your working directory is unchanged. Alright? If you do git reset hard, it also resets the file in your working directory. Okay? Read the difference carefully about mixed and hard. They're both useful, but in different situations.
Hard is if you have done lots of editing, you're experimenting with stuff, lots of changes, and after some time you discover, okay, this doesn't make sense, it doesn't work, I made a mistake, go back to the commit and clean up the working directory.
Yeah, you can do git reset hard in that case, and that will clean everything.
Especially when you have to apply some external patches, so you don't doing git operation, but doing by hand, deploying lots of stuff, you try to compile it and notice, okay, this guy gave me a patch in a Windows for a doc format or something like this, so this whole source code looks like confetti. Just go back and...
It's easier. Hard just means throw all my changes away.
Yeah.
Yeah. If you do hard, okay? Okay, now that we told you all this stuff, let's rock on the internet. It means that all this stuff that we see until now, it's on your computer. But Git works also with remote repositories. You manage them with the git remote command. So when you add remotes, you will fetch from the remotes the complete foreign repository in your computer. Let's see. For example, here I have my OLSR repository. If I do git remote, okay, you see that I have many. I have the official OLSR repository. I have Linux GitHub. I have my personal GitHub. I have 3 of them, okay, where I can push and pull commits. If I see at my tree, you see that Git keeps these special remote labels. So all the commits are in the database, and also I have some labels that tell me where the remote repositories are pointing. So for example, I see a master here, head, origin master. It means that the remote repository is there at that commit. To update this, to make sure I have the latest version, I can always do git fetch all, this will just load the remote commits from the remote repositories, okay, without altering anything. This I like very much, because before working I always do, for example, now you see I had some new commits that I just downloaded, and this will not alter anything in my local repository. I will just fetch changes to see what happened. So now if I do again the log, you see I have all this new work that is in the master branch, and this is the master branch in my computer. You see, master branch. I did git fetch, so there are all these new commits that I fetched from the network, and it tells me, hey, your origin master arrived there. So now I have a clear idea of what will happen. And for example, I want to update my master branch to have also these commits. So I want to pull these commits from origin and have it in my master branch. So let's see if I do git branch. Okay, now I'm on master. So now I can make git pull origin master, and it will pull this stuff. It shows me the changes. If I do git superlog, now my master is up there. Okay, note that I could do directly git pull origin master, but it's just me. I like to do git fetch, so that when I do git pull, I know exactly what will happen because I can see it before. Okay, let's see if I brought something here that made sense. Yes. So this is an example of git pull. In the same way, when you have some commits that are new that you want to push to the remote, you can do git push, and those commits will go in the remote. If you're not starting from scratch, but you start from a repository that someone else published, you can do git clone to download the entire repository. In that case, you will find a remote that is called origin by default that points to the repository where you did the cloning. Okay? When you do git init, you don't have any remote. If you do git clone, it's automatic. You have this remote called origin. See here? Origin, this was added by default because I first cloned it from the OLSR repository. These other ones I added by hand. Let's make an example of push. Now there are these new commits that I downloaded from the OLSR repository that of course they will not be in my GitHub. So I see here these special labels in red of the remotes, that the GitHub of Linux and the GitHub of my personal account are stopped at this commit for branch master, and I have some more stuff in master, you see? So I will just do git push to GitHub of my account master.
You have like 5 minutes left?
Yeah, I'm roughly finished. Okay. Okay, you see that now it went up there because it's updated the remote. Now if you go to my GitHub, you will see that I pushed something.
In fact, you see the commits that you pulled. You don't even see who pushed them. You just see the commits and the commit messages, I think. Maybe?
I just see on GitHub, you mean, huh?
On normal
No.
Git repository. Maybe GitHub shows you a little bit additional.
Yeah, it shows that it's updated 1 second ago, for example.